helping you with Acorn and RISC OS computing.
Okay. Well, good morning. Welcome to Wakefield that's in Bradford. I'm here on behalf of RISC OS Open Limited today, as that's rule. And if you've been to the stand, you can be delighted that finally someone's realised that there's a pun and you can buy rules. So it's a groan-worthy pun, but it's taken 17 years to think of it. But there are now actual rules on the rule stand. But we're not here to talk about rules, we're here to talk about RISC OS. So roughly, sort of riffing on the safeguarding the past, present and future theme, I've gone for some near-termism, some mid-termism and some long-termism. So we're going to have a quick look first at where things are with the next stable release of RISC OS 5, so RISC OS 5.30. So I like facts and figures. Got an A-level in maths, so let's talk some numbers. There are 9 ports of RISC OS 5 to various different hardware platforms, and a traffic light system in place. And I screen captured the traffic light system, realised it was actually quite complicated. So if you hover over any of these little bits of text, it tells you what work is being done in each of the respective areas, but it does turn out to be an absolutely massive list of things. And then there's also, so those are things that are hardware specific, and then there's also a sort of background list of bugs and new features that are being added, and that applies obviously to all things that run RISC OS 5. That's on a wiki page, so you can log in and edit it if you want to. And of that list, when I looked yesterday, that was 66% done. And then there are a couple of things sitting in review, so that number will jump to, I don't know, 75% in the next week or two, I would guess. There's a new edition of the user guide being prepared as well. That was an astonishing 89% done. So there are 6 chapters left to review and update in that. So if anyone fancies themselves as a proofreader and you're good at looking for split infinitives or double negatives, have a read at those last 6 chapters that are listed on that page, and you can help out finish off the last few chapters. In numbers, there are around 55 historical bugs that have been squished. The most egregious of them, as I remember, is in Paint. If you've ever used the Paint with Sprite tool, you'll notice that often crashed and has crashed for many decades. So that bug has finally been squashed, and then there are also what are known as CVEs, which are critical vulnerabilities in security land. So there have been 3 CVEs fixed, which are relating to the Acorn SSL for secure network traffic. And then rolled in with that, and we're going to have a look at that in just a second, there are 4 bounties worth of bits of work included. So this is just a zoomed-in version of that same set of slides, same table on the right-hand side that you saw on the other page. So each of the 9 ports have bits and bobs left to do on them. Obviously, some of them have already reached their stable status because they're, I guess you would say, historical platforms. So IOMD is the RISC PC. Obviously, the hardware that's made in the RISC PC has not changed, so there was very little extra work to do to turn that one into a stable release. So there's release candidates to try out of those 4 that are in green, and then obviously the other 5 have got various bits of work that still need to go. So we're hopeful, we're measured, because I call this near-termism, I'm hoping we're measured in days and weeks, not months and years. So we'll come on to the mid-termism later on, but RISC OS 5.3 on its way. And I very much liken it to, if anyone remembers, when the Grand National had problems starting about 15 or 20 years ago. So all the horses parade round showing their credentials, and they've all been weighed in, and then they come to the start line, and because there's so many horses to try and line up, you never quite manage to get all of them lined up all at once, and they have to go round again. And they tried with a tape for a while, and then they got tangled up in the tape, which is obviously going to happen. So then they got rid of the tape, and that then means that sometimes a loose horse vanishes off before everyone else. So we've kind of got to that situation now. We've got some loose horses, IOMD, Beagleboard, Pandaboard, and Ionics that are already available as release candidates for RISC OS 5.30, and then the rest of the horses in the pack still have a bit of work to do. So I'm just going to focus in on two particular aspects of new features in 5.30. So Paint, which has had a lot of work done on it due to it being in two overlapping bounties. The first one being the PNG bounty, Portable Network Graphics. So it can now export as a PNG or a JPEG. So previously you could only save from Paint as a sprite, so you can now save as a PNG or a JPEG as well. And they're very common file formats. So if you're wanting to send a screenshot to someone who's got a Windows PC, you would probably send it as a PNG or a JPEG because obviously they can't open sprite files themselves. The long-standing crash I mentioned about when using Sprite as a brush finally squashed. I don't know if people here use that feature as much as I do, but I always used to do quick save of the sprite before I ever used that tool. So now I can be somewhat less conservative and just go ahead and make use of it. So that's very good. There is an opacity slider added so that you can do blending in alpha levels. So rather than just a hard on-off of a sprite, you can have soft gradations and editing the resolution of a sprite on the fly without having to run it through change FSI, which is what you currently have to do. So if the magic of network and things is working, here we go using those exact features. So we're creating a sprite and we can give it alpha channels. So that all looks fairly familiar. And then if we go and pick the tool, which is the Paint with Sprite tool, that dialog box has got a lot bigger and it's gained its opacity slider. So we can search with a find button for the sprite we want to paint with, and then splat. That's at 12.5% opacity, a little bit darker, splat. And you've also gained a little palette of possible shapes there, which was also missing. You always used to just have to blind type the thing that you wanted to do. So now you get little thumbnails of the tool. And then my other favorite feature is the move with wrap option. So everything that falls off the corner of the sprite when you move now, you can have it wrap back round like a roll of wallpaper, which is quite fun. Obviously, if you turn off the wrap option, it behaves exactly as it used to do, and it just fills it with a background color. But that's quite fun features in Paint. And then the other thing, which kind of wraps up a couple of long-term projects behind the scenes of reorganizing the boot sequence, and this is so that it can be split up and delivered via a package manager. So when you come to the point of needing to upgrade from a stable release to another stable release, at the moment what you have to do is basically blow away your hard disk because there's currently no feasible way of tidily merging everything. So the idea of splitting up the boot sequence into discrete packages allows us to do, in the future, we'll be able to do automatic updates. The other thing in terms of new users, if you're downloading RISC OS to run on a Raspberry Pi and you use the Raspberry Pi imager, the first thing that you look at when it boots into the desktop, you think, oh, there's a lot of daunting, technical-looking stuff that I don't really understand. So we've added an option so that you can hide things like the boot directory, the scrap directory, the territory directory, things that people don't really need to know how they work, what they do, and they can all be hidden away. And both scrap and choices can now also be moved from outside the boot sequence, and that's useful for if you've got a backup program. You don't really want a backup job to be backing up your whole scrap directory. So again, there's a funky little video, if you press play. So here in this example, we've moved the scrap directory out into the top level so you can just so you can see it, and there's boot, which you're probably used to seeing. If you rummage into the filer settings, there's a hide system application directories option. And when you click that, zoop, they disappear. So it looks much more like a normal hard disk would do on a PC. If you then have a second card that does have a boot sequence and try copying that on top, obviously that would be a nightmare. So the filer will intercept that and say that this operation is not possible because you've got your boot sequence is currently hidden. So there's a safety net in there if you were to accidentally drag and drop something. Also, along with RISC OS 5.30, we're able to add the full read-write version of SparkFS. So previously, RISC OS Open gave the read-only version so that you could extract things. So there was kind of a catch-22 situation that we provide all the downloads of RISC OS 5 as zips. So how do you open the zip? So that paradox was always solved by providing a read-only version of SparkFS, but David Pilling has very kindly agreed to make the full version, the read-write version, available to RISC OS Open. So it's involved combing over 52,000 lines of code, very tedious work to try and work out what license conditions would apply to that, because obviously SparkFS, as well as supporting zips, also supports various other archive formats, and some of those have slightly quirky licenses associated with them. So those are all now available in the RISC OS Open GitLab for any developers that might want to tuck in. And in particular, having to think of the things about SparkFS that I've always thought, I wonder why it doesn't do that. So being able to rename within a zip would seem like an obvious thing, but it's actually surprisingly difficult because the way the zip file is constructed is it's all in series. So if you tried making a file name, say, just one character longer, what you would have to do is shift everything from there, that point onwards, along by 1 byte, just to add that one extra character in. So it's surprisingly complicated, and I can understand why David didn't implement that. But it would be it's a really obvious thing that would be useful to have. Then there's a few new kids on the block in terms of compression. So bzip2 is a particularly good compression format that's quite popular. So it gives you better compression, but it's a bit slower than zip. So there's various archive formats that could now be added to SparkFS. And then I've always wondered why, when you're compressing something, obviously it makes the desktop slow down. Quite a lot of us, or most of us, if you've got Raspberry Pi, now have multi-core ARM cores. You know, there's potentially 4 processors in your Raspberry Pi, but only one of them is actually running RISC OS. There are 3 twiddling their thumbs. So there's an option there that you could farm out some of the compression jobs to one of the spare cores so that then the desktop remains nice and responsive. Anyway, so that's all available to download from the RULE website, and it's also available in Pacman, so you can get that from the nightly downloads as well. On to the midterm. So this is so we were talking about RISC OS 5.30, we're thinking weeks, months. Midterm is kind of months, years territory. So you've probably seen at least one person from RISC OS Open talking in the past about the bounty scheme. So there's currently, I was checking, there are 6 underway at the moment, and one in particular that's started just recently is the biggest collected amount so far, with a whopping £14,850 is the USB bounty. So that's kind of a 2-pronged piece of work. The first one is to finish off some CDC, which is a very technical term again. CDC is a universal standard to allow you to connect Ethernet dongles of various varieties to a computer, where, that's how to describe it. Yeah, it's basically a generic USB class for supporting communications devices. So that's what the CDC is short for. So that's one part of the work. And then a larger part of the work that follow on from that, our objective there is to update the rest of the USB stack, because that is currently based on some work that was done in the, I'm going to say, the set-top box era, so it's kind of 2003-ish. So it's quite an old quite an old USB stack by comparison. So that's why we don't support USB 3 at the moment, is our stack predates the invention of USB 3. So that would be another potential outcome there. The other 5, I'm sure I've discussed these previously, the Git client, filing system partitions, updating the toolbox, TCP/IP networking, and Paint we looked at just a few minutes ago. There are 5 currently in the collecting phase, and I just got the numbers off the website this morning, so you can see whereabouts they are. Some of them getting quite close to their threshold. I did notice, because I had a set of these slides from the show in Bristol, and that was, by my maths, I think that was 8 weeks ago, 2 of them haven't moved since then, so I'm not clear whether these are just not very sexy bounties. So perhaps desktop-wide Unicode support doesn't sell it very much. Maybe I need to explain some of these. So quite a lot of, by their very nature, quite a lot of the bounties end up being sort of foundation-laying, not very visual things to look at. And I guess, yeah, the desktop-wide Unicode support is in that category. So if, for example, you were developing a web browser, although you don't necessarily go and look at a lot of websites written with Chinese characters, which would definitely need Unicode, even English or English and French and the Latin alphabet websites will almost all be in Unicode now. So the downside to that is, with RISC OS not supporting it properly, you end up having to render that via some other means, either by getting a load of fonts from a different system and then trying to translate them on the fly. It all makes everything run really slowly. So having RISC OS do that natively would be a great boon there. And again, the filing system improvements, they're kind of, again, another thing that's not massively visual, but we've kind of got to the stage now where the smallest hard disk you can buy from PC World is going to be probably 1 terabyte, and that's right near the limit of what RISC OS can currently support, which is 2 terabytes. Or 256 gigabytes if you're using 512-byte sectors. So the drive technology has caught up with the limitations in RISC OS and now overtaken it. So again, it's not a hugely visual or exciting thing, but it's the sort of thing that would unlock the rest of that spare space on a disk. And the other thing that I thought was quite interesting there, that the LAMMANFS, so rewriting the SMB network client that talks to Windows, has reached and exceeded. It's gone to 110% of its target. So it was quite exciting. And the important thing to take home here is that these totalizers, this is not money that's collecting for Ben, Steve, or Andrew at Rule to do a load of work for. This is, anyone at all can claim these bounties. They're all on the website, and if it's something that you're interested in, please drop an email or come and see me or Peter on the stand today and let us know that you're interested. And if you're excited by more behind-the-scenes details here, if you go to the bounties page, there's a more info button, and that takes you to that page where you can see the live status of the 6 bounties with blow-by-blow descriptions of what happened most recently, and also the 5 that are collecting. Enough of the midtermism. Let's cast our gaze into the long term a little bit. So this is a fabulous infographic with a mind-boggling amount of information on it if you look hard. So timeline is the bit in white, that's easy to understand, and these little map pins correspond to each of the stable releases that fit on that timeline. Obviously 5.30 map pin will appear over here. And the things up in purple at the top are the bounties that have started, completed, and delivered. So for example, I mentioned with Paint, there's the PNG graphics export, so that's up there on the bounty timeline, and the stuff along the bottom is when various new bounties were opened, and I imagine we might end up with another one coming soon here. But if you were to slide that graphic over to the left-hand side a little bit, off the end of the timeline, there's always a pile of things that I think, well, yeah, that would be really useful if RISC OS had that, but, well, okay, we've kind of got quite a lot of stuff, a lot of plates being spun at the moment. So there's always a little thought bubble cloud of various things that would be really nice to do. But some of these are quite chunky. So if I look at that in Iceberg terms, the bounty scheme has been thawing out the little ice cube perched on the top of one of the shelves on the part of the iceberg that you can actually see. But as we all know, most of the work that we can't see is hidden under the water. And that's where, there's kind of a middle ground between something that's of about the right size to run as a bounty that a developer can tackle in weekends or a few weeks of work. And then there's this bigger chunky stuff that's going to take many months and potentially years of development effort. So just picking a few of these, how are we doing for time? Okay, I'll try and talk quickly then, because there's quite a lot in orange here. So just very quickly picking on the ones that seem to be the biggest, chunkiest pieces of work that never quite get done. They always end up, every time a new year appears on the timeline, these bubbles just shift 1 year to the right, never quite get tackled. So there's 9 here I'll very quickly talk through. VFP legacy emulator. So the idea of that is, at the moment, for floating point support, we try and emulate an FPA floating point unit, which actually dates back to sometime in the mid-90s. And the only computer that's actually had an FPA on it is the A7000 Plus. That's it. No other computers that we can currently run RISC OS on have FPA hardware. Quite a few of them, though, anything roughly after 2002 onwards, have VFP. So the idea here is to write an emulator that allows the stuff prior to 2002 to then start using VFP instead via emulation. So that then means you can flip the table around so that anything that's a recent computer runs it on the hardware, and anything that's older than 2002 would then run it through emulation, which is slower. So that's the idea behind that one. Bluetooth stack, it's a nice little bit of work on the side. There are various Bluetooth peripherals. In fact, I suspect you can get things like headphones that pair with your car if you've got a recent electric car. But much more akin to things that you might want to run with RISC OS would be something like a printer or a keyboard. So being able to pair the simpler classes of Bluetooth devices in the same way that you do for a USB keyboard or printer. And we've got a couple which we can knock out in the same category of rewriting the basic interpreter in C and rewriting the window manager in C. So at the moment, both of those are written in lovingly handcrafted assembler, which is great for speed, but really bad for maintainability. They're quite difficult, or it limits the subset of people who are able to understand how to maintain those 2 bits of RISC OS to only people who are wizards at writing assembler, and there's not very many assembler wizards in the world. There are a lot of people who can write C. So that's the idea behind that, is to try and open those up a bit into a language that gives you a wider pool of people to choose from. Now, so let's pick another difficult one from around the side. HAL hypervisor. The idea with that is that we spend an awful lot of time with RISC OS 5 porting to the next big thing. Another new computer comes out, and you have to spend 6 to 12 months writing all the drivers. Oh, so many UART drivers. It takes ages. So the idea there is that instead of writing all the drivers yourself from scratch, is to run RISC OS on top of a hypervisor, and a hypervisor is then something that can live in a guest OS. And the advantage of that is that guest OS, they're the ones that have to write all the drivers. So you're cutting out a load of repetitive driver work that we keep finding ourselves doing that takes an awful lot of time. And instead you do it once, and then you run RISC OS as a hypervised OS inside a host OS, and that avoids you having to keep writing lots of drivers. So that'd be a nice time saver if that were to happen. I talked a moment ago about things that weren't very visual, very easy to see. There is actually an objective here of having a fresh new visual theme. So we've still got quite a lot of icons that all have the same metaphor of a sheet of curly paper. It'd be really nice to be able to have a graphic designer hired to design a new set of file icons. It's actually a surprisingly large job. When I was counting up the number of sprites there are supplied with RISC OS, it's about 400, something like that. So if you think, well, how fast could I design a graphic? It's probably an hour or two per graphic. So immediately you've got like 500 or 800 hours of work there, which is an awful lot of design work. But it'd be really nice to have a coherent visual theme that somebody who's come from another operating system would be familiar with seeing. They do tend to go through slight fads and trends. So you saw me setting up my Windows laptop to project this. And at the moment, Windows is very much in a square, flat theme. Windows XP was a rounded corners, sort of Teletubbies theme. So they do tend to go through fads and phases. So it'd be nice to be able to have another theme to be able to choose from the palette of themes that we currently have. Which ones haven't I done now? So there's just only these 3 left. I hope I'm doing okay for time. 5 minutes, okay. I've only got 3 left and 5 minutes, I can manage that. So the Programmer's Reference Manual is a mighty 4,000-page tome, which if printed out, it's probably like, I don't know, about 9 inches tall of paper. And the problem we have there is that the content, although we can generate the manuals, the content within the manuals is still really describing RISC OS 3. So all the things that have been added in RISC OS 4 and 5, so that's things like PCI buses, which didn't exist at the time of RISC OS 3, USB, obviously, multiple graphics cards, all those sorts of things aren't currently described anywhere. And the only way you can figure out how to use them is if you go rummaging around in the source code, which makes things very difficult to find. So having a new coherent set of programmers' reference manuals would be great. And the last two, which I can bat out quite quickly, C++ is a programming language not unlike C, as you can guess from its name. I'm afraid I don't get on with C++ personally, but I know that it's a very popular programming language, and it doesn't really have that great support in RISC OS at the moment. So one thing on the journey towards that's going to be shoehorned into RISC OS 5.30 is support for C++ applications. There are a couple of hooks that you need when they first run. There's a load of things called constructors that get run, and then when you quit them, there are things called destructors that get run. So at the moment, there isn't support for that in the shared C library, and that's one of the things that's being added in RISC OS 5.30 in anticipation of that. And then this last splodge here, multi-core support, is, like I said earlier, we've got 4 cores on many ARM processors now, but only using one of them. So it'd be really nice to be able to harness for a 400% casual 400% speed up of your computer for no effort. Would be really nice. So yeah, basically these are all big chunky pieces of work, and although the bounties have delivered a load of great things, with 12 of them complete so far and 6 currently in progress, as I said, you have to acknowledge that probably in computing world terms, really all we're doing at the moment is treading water. We're just managing to keep up as technology, as hard disk sizes get bigger, we just managed to add support for that at the corresponding time and never managed to actually get ahead. So some of these, yeah, they're really big, chunky pieces of work that could take several years if run as a bounty, even just to collect the amount of money that the developer might want to claim them. So there's going to be some kind of a new approach needed of some sort. It's not quite fleshed out yet, so that the big pool of developers, there are many millions of software developers in the world. It's just there aren't millions of them working on RISC OS. So that's the bit that we need to try and work out, well, why not? So is it that when we've worked out how to run a bounty, it's calculated out at minimum wage? Maybe software engineers want paying more than £10 an hour. Oh, I don't know. So there's definitely a big a step change needed in order to develop some of those big, chunky pieces of work, multi-month or potentially multi-year long pieces of work. It's a different ball game to the bounties that we've run to date. As if by magic, hopefully I haven't run out of time. If there's any questions, hopefully easy questions, please. I'll try and answer them. And if I've run out of time, you can always come over to the stand and talk to us there. Aha, question on the front row.
Tell you what.
You say the question. I can read it back. Yeah, I'll shout the question.
I was a bit alarmed by the 28 things wrong with IMX6 in the... Can you say something about that?
So yeah, each of the ports, so behind, if I go back up to the chart, yeah, each of the ports goes through a assessment before a stable release starts. Somewhere there's a link. No, there isn't a link here. So underneath this text, if you were to go to that page, there's a link to the stable release criteria. And some of it's very technocratic, like if you've introduced a new module, the error block needs to be registered. So if you then look through the source code and find out, oh, actually, no, the error block hasn't been registered, it's using 0 as the error number, then that would count against you. That would count as one of your pieces of work that needs doing. So within that, I don't remember off the top of my head what the 28 things are, but I would say 15 of them are little one-line changes like registering the error blocks. And then there's some more meaty stuff in there like detecting the Ethernet chip, I think is one of the things that isn't done correctly there. So yeah, it's a mixture. It's not to say that there's 14 times more work than titanium or twice as much work as the Pine book, for example. It's quite a lot of them are just little tasks, little niggly tasks.
When 530 goes out, will it still work on the IMX6 with some problems or not?
Yes, so all that would happen is there would be no stable release for the IMX6, and then the following day, RISC OS 5.31 would be available for the IMX6, yes. So it's not a reflection, the red light is not it's being discontinued. Yeah, it's that there just wouldn't be a recognized stable release because it hasn't met the stable release criteria, yeah. Hello.
When it comes to the Raspberry Pi, there are 5 issues remaining there.
Yeah.
Are you hoping to get those sorted before 5.3 comes out? One of them, I think, is a problem with SDIO on certain models of the Pi that was not expected and so emerged recently as a problem. Could you just sort of comment on that? Because there are so many Raspberry Pis out there, and it seems quite an important area, really. I mean, there can't be many Ionixes left.
Yes, so the Raspberry Pi one of those 5 things, again, you're testing my memory of exactly what the 5 things were. One of the things, you're right, is effectively a regression. It's something that used to work in 5.28, it now does not work, and so someone needs to fix it. Yes, and then there are a couple of other things. I've remembered now, there's the Pi 400, one of those, in order to work around chip supply problems, they changed one of the chips, and that doesn't work with RISC OS. I think I might have volunteered to do that. It's foolish of me. So yes, there is a small amount, hopefully, of work to battle those through. So it's like the horse racing analogy that I gave. The horses are circling the pen, and yes, ideally, the one, there's clearly ones that have only 1 or 2 things, or single digits of things are probably a few days of work to fix, and the things with more than 10, maybe they're a few weeks to fix. So it's all within grasp, and I think you're right to say that the Raspberry Pi is obviously a key platform that attracts more users than any of the other platforms added together. So it would be wise to try and get the Raspberry Pi one over the line. In terms of when you were saying there's not many Ionixes, it's not that that's consuming a lot of time, people's time working on it, because the Ionix is exactly the hardware that was built when the Ionix was built. Nothing new has happened. Therefore, when you run the sausage factory, turn the handle, an Ionix sausage falls out the other end, you go, well, yeah, that works. So it's the ones where you have new hardware, new variants of the Raspberry Pi coming along that you then get tripped up. Everyone's happy. I've either bamboozled you all, or you're all thinking it's nearly lunchtime. So I'll assume it's the first one. Okay, no problem. Thanks a lot.